A wonderful good afternoon, dear LinkedIn community and Composites fans out there. I'm really having the honor today to host a very, very special show that is basically a part of the JEC Startup Booster Competition. So today with me are the 5 finalists. Actually, these 5 finalists have applied for the Startup Booster Competition. And what happened is they have been selected as the 5 finalists and they will be pitching now live to you guys. What we will do, and I need your help now during this show, we are not looking for the winner of the Startup Booster Competition because that is the responsibility of JEC on the 23rd of November in Frankfurt. What I would like to select with you guys is the winner of the hearts and the minds during this LinkedIn live show. Let's see who will be convincing us with their innovative idea. Let me shortly show you first of all the participants. Let's go one after the other. So say hi to everyone, and everyone out there listening and watching today to us. Please use extensively today the chat function. So this LinkedIn Live is a live show where you can use the chat function, ask your questions and do comment. So please comment anyone on these, on their innovative ideas. Do you find it suitable? Is it innovative enough? What are your criteria for winning such a startup booster challenge? And I prepared a few slides and I will run through these slides with you once I get that added to the stream. So just to give you an idea, my company is IMBEO. IMBEO stands for International Management Business Executive Operations. You don't need to remember those. It's just a fantasy name until Google said, okay, this name doesn't exist on the net, so I chose that. So what is my main dealing today here? We are here to promote and introduce you to the JEC Forum DACH. This is a absolutely new format in the DACH region for the composite industry. This format has been already introduced by Eric Pierjean, whom I greet now. He's right now in Korea. And you may visit the website www.jec-dach.events, or you can also see our LinkedIn live stream or the podcast to learn more about this JEC Forum DACH. Let me introduce myself to you because some people are asking, so who is Ilkay? Ilkay is always present on LinkedIn, but what is the relationship between what he does on LinkedIn and composites and what we are talking today about innovation? So I've introduced you to IMBEO. This is my consultancy business, and within this consultancy business, I'm giving services like marketing, PR, business development on composites. Composites companies, composites associations, and as you can see, composites events. Then I'm also, on the left side, you see the European flag. I'm also coach and innovation coach of the European Commission. So once they are giving you a grant, the beneficiary that takes the grant has to take an innovation coach. Why does he have to take an innovation coach? The innovation coach basically makes sure that everything that is in the concept of the innovation in the end makes sense. It gives you coaching facilities, it gives you the ideas to run them through with your coach to see whether all the innovation that has to take place will have also a chance on the market. So I'm doing about 15 to 20 days per year only on innovation coaching, and that is the reason why I'm so happy to have the finalists here, because all these 5 finalists have extremely nice innovations in their pipeline. And last but not least, you see on the right side my the LinkedIn logo. I'm a content creator here on LinkedIn, a LinkedIn live host, and this is how and why we came together. What I would like to start now with you guys is, why is innovation important? Yeah, everyone says, let me innovate something, but why should you innovate? And why I'm calling the community to be innovative? Yeah, and also please now write in the comments, what do you understand under the term innovation? Because I'm seeing a lot of people have a different understanding of innovation. Let me know what you think of innovation. What is a clear innovation to you? One of the definitions I made for myself is innovation is the only power disrupting the way we live, learn, and or work. Now, while you are listening to the pitches of our 5 finalists, also reflect, what are they changing? Are they changing the way the people will live in the future, learn in the future, or work in the future? And you will see each one has different of these aspects available in their pitch. So let's start the pitching with our guests. This is the row. Ladies first, of course. Laetitia will be the first to pitch. Then we have Jörg, then we have Michael, then we have Martin, and then we have Robert. Robert is a bit tight on time as far as I understand, so maybe Robert will be jumping off a little earlier. We will see how everything goes. But let me now take everyone out of the scene and only Laetitia in. And let's start with Laetitia and her pitch here. How is the vibe, Laetitia? Are you excited?
Yes, I'm excited, but I'm also glad to be here with you on the LinkedIn Live. So thank you very much for this invitation.
You're welcome. And Laetitia, you are joining us from the nice wine region of France, Bordeaux. Yes. So this is very important to know for everyone. What's the best time to visit your area?
I think it's on the summer and also during the winter. Both seasons are very, very good to visit Bordeaux and drink wine.
I've been to Bordeaux, but it was more, I think, the transition from spring to summer. Okay.
Yes.
Laetitia, I give you now 3 minutes, up to 3 minutes, to pitch your idea in the most concise way as you can do. You don't need to be excited. We have a few live followers and a couple of thousand people will see this live later on. Don't need to be excited at all. Just do your best as you can. I take you to solo and wish you all the best.
Thank you. So good morning, everybody. I'm glad to be here. I'm Laetitia, business engineer from Touch Sensity, and we are making materials speak. So we are a 9-person deep tech startup of more than 1 year old. And so we are developing an innovative technology that makes all the materials sensitive to physical interactions as pressure, traction, deformation, as bending, and even damage suffered by a material and in real time. So how does it work? It is an embedded system connected on the periphery of the material, and it will work as a transmitter-receiver. So it will send a signal inside the material and receive it. And then using a processing system with mathematical models or artificial intelligence, we will be able to compare both signals and then detect the interaction, characterize which type of interaction it was, measure its intensity, locate it as a 2D or 3D mapping, also interact with the system using feedbacks, and also adapt to dynamic environment. So thanks to the Sensity tech, we can meet needs of structural health monitoring for non-destructive tests. For example, just come and check the part and see if there is a good quality. And also during the system exploitation to do predictive maintenance. So it is really the material that becomes a sensor, and we can have a volume analysis, a surface analysis, and a global vision of all the material and its health. And also we can do it in real time. So now let's just imagine you want to know what's happened on the airplane structure. Using the Sensity tech, you can be able to detect any deformation caused by passenger luggage or any impact caused by birds, or even a damage caused by the previous impact maybe, in order to alert the maintenance team and allow them to act quickly. So Touch Sensity, it's 6 proof of concept realized, also 2 collaborations with Ariane Group and the ECNCF. It's our first fundraising of 1.2 million euros last year. So at Touch Sensity, we want to be the world leader of the connected materials. So if you're a CTO or an innovation director on the audience, please feel free to add me on LinkedIn, and it would be a pleasure to discuss with you about the technology or even your application.
Fantastic. Thank you so much. Clap from everyone. So please, everyone, now write down in the comments, how did you find Laetitia's pitch? I find it great. I have one follow-up question, and I try to relate this follow-up question always to your pitch. I had the other day Jörg Bai from Bai Aerospace with me. You mentioned planes. Let me show Jörg's plane. This is a fiber reinforced plastics plane, an electric plane. So you are saying basically you can put these sensors into the fibers, into the textile product, which is probably a roving or a biaxial product. Is that correct?
Yes, it's correct. We can connect the embedded system via connectors on the fiber, on the carbon composite, for example.
Okay.
And then it will become the sensor.
Okay. Are these data then collected? Is that, connected with the wiring system of the plane, or is it, giving some waves and that waves have to be collected?
Yeah, the embedded system is connected using wires, so connectors to the material, and then between the embedded system and the processing system, it can be Wi-Fi or Bluetooth, for example, or also communication way.
Okay, wonderful. Laetitia, please write in the comment now. You will be free for a couple of minutes because your colleagues will now pitch. Write down in the comments where the people can find more information about your embedded system. Okay? Thank you so much. And next is Jörg. Yes. So Jörg, welcome to our show. Fantastic view you have there. Tell us from where you're tuning in right now.
Yes, thank you for having me here. I'm joining in from Linz in Austria. You see the skyline a little bit behind me.
Okay, Linz, Austria. I know Linz very well. When I drive here from Bayreuth through Passau, Wels, then I cross Linz to arrive at Wien in the end, right? So you are on my way to Wien. But I've made a lot of stops and I have a few friends also in Linz. So welcome, Linz, to this show. Jörg, without further ado, now it's your time. And please convince our community about your innovation. Go. You got 3 minutes.
Yeah. I founded Carbon Cleanup to tackle the issue of carbon fiber recycling. 2020, in January, we founded our company after some pre-work. I worked quite some time, or a long time in the industry, developing carbon fiber materials for wind energy applications, aerospace applications, other leisure goods. And as we all in the community are aware that recycling is a big challenge, I thought after some extra experience in the machine manufacturing industry that it would be time to really solve this problem. So what we invented, based on a patent, we have a mobile recycling solution, which is the size of a container, basically. This recycling unit is connected, digitally connected also to collection pods, like waste bins, which are equipped with Vision AI systems, which we developed. And those Vision AI collection bins will or are analyzing the material and classifying the waste materials. We all know that we have a very high scrap rate still in composite industry during manufacturing of those maybe fancy planes, as you showed before. And even in these days, developing new concepts like electrical planes or other lightweight, very lightweight requirements, this issue will still increase, we believe. So what we do here is we really want to prepare the material. So we are in the first step. We classify the material and we prepare the material to be used for other applications. We do so on site, so we have contracts with partners in aerospace industry where we get the material and work with the material on site, closing the loop. That's the ultimate goal here, and to ban or to get these materials out of landfilling, which is the common procedure today. Up to 99% of the material is still landfilled. And it's a complex waste, as we all know. So we target carbon and glass fiber materials. And our system is in the prototype phase. So we did first tests and have the final setup from our collection system to our cleanup unit, the mobile recycling unit, until this year end. So we have quite some good progress here over the last 1.5 years. Crisis didn't really stop us, so we could do a lot of development work. We built up a team of 10 people up to date and are hiring 3 more until December. So what is our plan for this system? We want to serve the market with a real solution. So our solution is mobile, can be used in several different plants for big corporates. So we guarantee a unique recycling standard, maybe from South America to China. So our recycling solution is a real stable process. In the end, we sell these recycled or upcycled materials, which are in the major case or in the better grades we can produce, are blended with thermoplast materials, standard materials, because we are aware that those upcycled or recycled materials will not be used for high performance applications, but there are many high volume applications for fiber reinforced plastics. This is our segment where we work in and also develop with our customers. Finance wise, we got some good funding, public funding, and very happy to be here also in JEC DACH competition with you, Ilkay. Thank you again for having us, and I hope that people see our project positive and vote for us in the end. Thank you.
Yeah, thank you so much, Jörg. Wonderful pitch coming from Linz. If I was the jury, certainly you are one of my top favorites, because recycling is, of course, an issue of sustainability. You know, we know these, plastics being in the dump everywhere, and they have thousands of years until they degrade. So any solution that can reduce this problem is, of course, welcome. Now, my follow-up question to you, Jörg, is the following. Now, in the composite industry, let's be a bit self-critical. We always strive for the best technical specification that we can achieve. We want strengths, we want durability, we want torsion resistance. Now you are coming and you basically have a method of, getting these recycled. And did I get it right? You want to sell these fibers?
Yes, we are in the area of mechanical recycling here. So that means what our goal is to have lower CO2 emissions for our recycled materials than for new materials in the same performance category we are targeting. So we are realistic about that. The energy consumption of our system is highly critical, and so we keep resin and fibers together to tell that here and go to other industries with this material. Could be from aerospace going into B2C market, for instance, or other industries with different parameters of use. Yeah.
So basically, you are not dismantling the material from its matrix. The matrix and the composite remains intact. You just classify the different kinds of FRPs, and you would sell these to the construction industry, maybe garages that have a second life for this.
Exactly. By those high integration of digital means, we know what we have, which is a major task in recycling, is to know what you have. And we do this in the moment when the customer throws away his waste. We analyze what it is, we know where it is, what's the value of the material, and what can be the solution to use it in a low CO2 impact manner. Yeah, that's very important, because to do 7 process steps to win a fiber back, to again make a yarn out of it, to weave it, to impregnate it, to cure it, is, from today's perspective, very, very hard to achieve a positive CO2 level in this respect.
Correct. Yeah. So Daniel Coughlin, thank you for joining and your comment. He says the optical characterization of scrap is very interesting. So you got already some fans here, Jörg. Wonderful. Thank you so much. And I will give you now a short pause. Please write like Laetitia in the LinkedIn comments where people can find more information about your innovation. Yeah. And
sure,
next will be, yeah, thank you. And next is Michael. Michael,
hello.
Welcome to our show. So, Michael, you are not so far away from myself. I believe you are in Dresden or near Dresden.
Yep, exactly.
Wonderful. So we have only car drive 2.5 hours away. Beautiful Dresden. Yeah. The Elbflorenz, they say. Yeah.
Yes.
A beautiful city. So anyone who wants to visit Germany, Berlin is nice, but Dresden is also a tip from myself. I've even seen yesterday a post of Jan Geier, one of my followers, who was in your museum, your traffic museum, and there is the supposedly first engine displayed in Dresden. So have a look at that museum as well. Okay, so Michael, yeah, so it's your time for the pitch. You got 3 minutes. Die Uhr läuft.
Thank you, Jörg. Hello, everyone. My name is Michael, and I'm a co-founder of ANYBRID. In using lightweight engineering and high-performance materials, we have succeeded in transforming the conventional thinking of plastics processing. We developed the world's first mobile injection molding machine. We call it Robin. Robin only weighs around 140 kilograms. Like this, it can be mounted on classical industrial robotics. So we are taking the injection molding process out of the center. We think it is a process that can be integrated into other manufacturing processes. For example, like the extrusion or pultrusion processes. And just imagine, 80 billion euro is the yearly turnaround of the plastics industry just in Germany. 80% of this is somehow connected to the injection molding and the extrusion process. But today, these two processes are completely isolated from each other. And think about a typical technical profile that is made in extrusion: a rod, a pipe, or a beam. You always need couplings, fittings, or sealings in the later product. These elements are traditionally injection molded. So we found out that in many manufacturing lines from today, these elements are joined in manual processes using gluing or welding. So in the end, this results in additional costs and labor. With Robin, we can integrate the injection molding process into moving processes like extrusion or pultrusion. Like this, we can directly overmold the profiles in the processes. So in the end, we increase the degree of automation and decrease the need of labor. This is just one application field, and right now we are discussing with many customers different components and material combinations. Besides plastics or composites, we are discussing to overmold textiles, metal, or even wood. We are thinking of many different industries that can benefit from Robin, starting from the jewelry and furniture industry up to the automotive or aviation industry. We rethink traditional ways of manufacturing in making injection molding fly.
Michael, how many times did you exercise this pitch?
Oh, well, a couple of
Many
times.
No, it's really good. Has a great chance. Wonderful. So my question to you now is my impression right? So we are not talking purely composites here, but it can be combination of materials. Of course, it has to be some sort of polymeric injected here.
Yeah, well, it's a classical injection molding process. And So composites are in our machine in two ways. On the one hand, our machine is made of composites, made of CFRP, and on the other hand, we can overmold onto composites using injection molding.
Wonderful. Okay, wonderful. Very good. Michael, please write in LinkedIn, not here in the private chat, in LinkedIn, where people can find more information about it. Jörg, please also put your information into LinkedIn. Thank you so much. Next in line is Martin. Martin, welcome.
Welcome.
Martin, you have a very, very interesting solution, and you fall a bit outside the others in that you have in German we call it Bauteil, English component that you are manufacturing as a composite. So I'm really eager to learn more about it. The stage is yours. You got 3 minutes to pitch.
Yes, thank you, Ilkay, and thank you for having us or letting us participate here. My name is Martin. I'm one of the founders of Carbon Drive. We are here in Weiterstadt, which is between Darmstadt and Frankfurt. And actually, we are originally, our roots are at the Technical University of Darmstadt. But in 2018, we left the campus and the university surroundings and founded our manufacturing hall and so on here in Weiterstadt. And our main component, or as you called it, is motors, highly specialized electric motors. And we make all the structural parts out of carbon fiber. And the special motor that we focus on from the beginning are motor spindles. So I give you a first introduction maybe what motor spindles are for. So everybody probably knows this kind of tool. It's like a mill, and in basically all manufacturing processes, be it in the automotive industry, in the wood industry, or in the furniture industry, and airplane industry, everywhere you need the tools that manufacture or that remove material so that you get parts that have the correct dimensions and tolerances. And so to drive this kind of tool, you don't do it by hand. You need some kind of electric motor like this. So this is actually one of our first products. It's a 10 kilowatt motor spindle, which weighs around 4 kilograms. And you directly see, so this has an interface where you connect the tool. And this is actually the main function of this motor spindle. It has to clamp the tool. It has to be extremely precise to reach precise machining results, to get good components. And then, of course, it has to be very fast. The spindle needs to accelerate very fast. And because you have to move the tool around a lot, the spindle has to be moved around a lot. So you see directly the benefits of a lighter spindle. And actually, because it's such an important part of modern machining, the steel spindles, traditional steel spindles, are extremely highly sophisticated, and they have reached the physical limits of steel. So with steel, you always get a certain density, a certain stiffness, and a certain thermal expansion. And those factors limit your processing capabilities. So for example, if you have a thermal expansion, the tip of your tool changes with temperature. So you need very expensive sensors to measure if this tip is moving and to correct this in your milling process. Otherwise, you get problems with precision. And the same is for the heavy weight of steel. This, of course, limits your dynamic stiffness. So the tool, at some point, you're milling and it will start to chatter. And here, if you have a lighter spindle with more stiffness and better damping, you can machine much more stable. You get better surfaces and more material with the same parameters. So with steel, with a steel spindle, you can maybe mill 10 millimeters deep, but with carbon fiber, you can mill 20 millimeters deep. So your machine with the carbon fiber spindle is not only uses less energy because it has to move less weight, but it's also more precise and produces more parts. So basically, we break through the physical boundaries of steel and utilize carbon fiber to its fullest potential. And yeah, so that's our product. And of course, once you have made this very sophisticated electric motor and use the benefits here, as you all know, there are a lot more electric motors in the world that are moved around and that have critical applications and that can possibly benefit from our technology. So yeah, please contact us if you need any light drives, and we can help you there.
Okay. Thank you, Martin. Very, very interesting solution, very interesting component that you have brought up here. I was wondering all the time already why these motor components have not been lightweighted for the future or currently. So my follow-up question to you is, what was the reason to put carbon here? Or let me ask two questions. One question is, what kind of process do you use here? Is it a filament winding, or what type do you use, and how do you make the hollow structure? And secondly, what was basically for you the reason? Was it lightweight feature, or was it the strength, or a combination of both?
Yeah, so the first answer, yeah, we use filament winding here to make our parts. We actually built our own filament winding machine because in those spindles, in the manufacturing, you need like a cooling system, and you need lots of different media, like air going through it, and other things like electrical sensors you need to integrate, and so on. And we developed our own winding machine that can directly produce in the manufacturing process, like those channels and so on, so that we get the most benefit of our additive manufacturing process. Yeah, so that's the technology is basically filament winding added with some special know-how, I would say. And the main focus originally was actually came in 2009 out of the industry for tooling machines and for spindles, and because they realized they to reduce this thermal expansion. There's a solution where you like in the rotating shaft you implement a cooling circuit. So you put water into the spinning spindle so that it's turning with maybe 20,000 RPM, and so you have to run water into the shaft, through the shaft, and back out to achieve like a cooler spindle to get a hold of those thermal expansions. And of course, that's a very expensive process, and it's not really important for the machining. And with carbon fiber, we get this for free, basically. Yeah? We have to put a lot of effort into the design and how we make a zero thermal expansion. But of course, then no matter what the temperature is, we have no tip movement. Yeah,
Martin, I have to stop here. Let's move to the next pitch. We can come back to your spindle later on. I also see some of our viewers, like Oliver, has asked already questions. So your technology is gaining a lot of track here. You're a hot candidate for the winner seat today. Let's see how the things evolve. Now, next in line is Robert. So, Robert, welcome to our show. Thank you for joining. From where are you joining, Robert?
From the beautiful city of Aachen, in the most western part of it.
So you are close to Belgium, close to France, close to Luxembourg.
In the heart of Europe, you could say. Yeah.
In the heart of Europe, absolutely, absolutely. Okay, Robert, let's start immediately. Let's jump off. What is your innovation about? Tell us your idea, sell it to us.
Thank you. So I'm Robert. I'm one of the co-founders of FiberCode. And FiberCode is a startup of RWTH Aachen University. We've been developing this technology since 2014, but we decided to found the company in 2020 so that we could leverage all of the time we gained from the pandemic. With that time, we figured out that we want to do high-performance materials that can have a real impact in society. High-performance materials are materials that work for many applications. They have great properties and great potential in cars, airplanes, and also everyday products. Actually, the more sophisticated the material gets, the better it could be used for many applications, But then the big problem of these materials is coming too, which is a very high price. Usually, using the best solution is not viable because it's too expensive. And this is what FiberCode is going to tackle. We are developing high-performance materials that are affordable and reduce the cost in using them to allow for more applications with better properties and for more people to use those applications. Our very first product is an aluminum-coated basalt fiber. By leveraging the basalt fiber's strength, spinning lines, and production capabilities, adding an aluminum on it, we get a conductive yarn, which in comparison to other conductive yarns, needs only one production step instead of 10. It saves up to 90% of energy while being produced, and it is produced very quickly. So we can produce it 10 to 20 times quicker than conventional production. This allows us to offer this material at 10 times to 20 times cheaper prices than the next best conductive fibers, and to go into mass markets, opening up applications in automotive for the shielding of EVs, in construction for the shielding of buildings and hospitals, or in electronics, and so on. We basically produce a fiber-reinforced fiber which has all the properties it needs and doesn't even cost more and even costs less than aluminum foil. We believe that by changing these basic building blocks of our society, of the products that we use, of the things that we build, we can have a great impact. And by making these materials affordable, we can also impact more and more layers of our society, more and more people can use these materials. And in order to achieve this, we are right now scaling. So we will achieve a capacity of 10 tons of our fiber material by the end of this year. And with the funding round that we just closed, we're going to increase that even further next year, hoping to impact many lives and to make living on Earth safer, more convenient, and affordable for everybody. Thank you.
Wow. Claps to you. Thank you so much, Robert. This sounds very exciting. Now, I've worked with fiberglass, aramids, basalt also, but more in a wool form. So I guess you are talking here about not about staple, but roving type, endless fibers. Is that correct, the assumption?
Right. We produce endless fibers. We can chop them to cut fibers. We can bundle them to thicker yarns. But yes, we produce endless fibers, rovings.
Okay. And what is the diameter of these fibers, and do they have an effect on the performance? Walk us just through a few examples.
Okay, so our current fiber is 22 micron per filament. We can produce anything up from 30 tex and above. And it has like a 2 micron aluminum layer on every single filament. And this, when you use this, you can use it as a textile, for example, in a fiber reinforced plastic. You would use one layer. It would give you the strength of the basalt fibers and add shielding that is used by the conductive fibers. You can also use them as sensors, but the main effect is they can have an EMI shielding fiber reinforced plastic, which you can then use for battery casing in an EV, for example. So you can shield off all that radiation going in and coming out of those devices.
Okay, so now being a textile guy myself, putting aluminium on as a coating, as a binder on the fiber, how are the textile behaviors? I mean, the haptics, or even how do you get it through the loom, the riyets on the weaving line?
Okay, I'll be completely honest with you. Sizing. Sizing is very hard to do. We found out a good sizing that actually is then on top of the aluminum and helps us go through the looms. And then it just is processable as any other textile fiber. I mean, like any other glass fiber or carbon fiber. Obviously, it's not a cotton fiber, but it's processable as any other. And from the feel, you feel it is metal, so it feels cold, right? You get the thermal properties. You feel those on the yarn.
Wonderful. Okay, thank you, Robert, for all your information. Now I can take everyone into our live stream here, because we got a few questions, and let's answer these one after the other in the chats. I think you guys have been already answering most questions. I'm going from last to oldest, yeah, or the recent to the oldest one. So Oliver says, sounds interesting, Martin KLIMACH. Do you use also pre-preg windings, winding tubes? And you've answered that. Maybe you can answer this once more for the community.
Yes. Of course, yeah, we use a traditional filament winding with wet resin and impregnating the resin or the filament before it's wound onto the mandrel. And for some parts, we use the hot press process where we use pre-preg. But the main structure, we use filament winding because, of course, we can very accurately decide what mechanical properties we achieve with filament winding.
Okay.
So
Then
that's
Marcus,
a big benefit. Yeah.
Yeah. Okay. Then Mark Opitzer asks, what about the robustness?
Yeah, the robustness, of course, in traditional lightweight design, you always have questions with the robustness. In machine tool structures, the only question is how stiff can you become? So you have a certain area that you can fill with material, and you fill it completely with material, so you get as much stiffness as possible. And then strength-wise, robustness-wise, we are always over all limits. So we do the calculations for strength, but we are always on the very, very secure side. So there is no problem with robustness. And,
Okay.
Yeah.
Great. So Yannick is asking, Michael, what about merging Robin and additive manufacturing? So with Robin, he refers to the acronym ROBIN. Maybe you can remind us what ROBIN means.
Robin stands for robotized injection molding, or short Robin in the end. And that's the machine that we developed that you can see in the background, that background. And well, we are up for any integration when it comes to different manufacturing process. You always have to find the right combination of the cycle times of the processing windows. But then there could be even a chance for additive manufacturing. You always have to keep in mind that additive manufacturing works without a mold, right? So you have just your structures that you are 3D printing, and with our process, you are back to the injection molding setup, and then you are injection molding onto some components. And so you always have to, you need a mold, and you at least need some parts that, yeah, you can afford the mold for it.
Okay, wonderful. Then we have another question for Laetitita that came from Daniel. Great application for automotive interior haptics, he says.
Yes, indeed, it is possible to make all the materials sensitive, so it is possible to do tactile surface, and as we detect pressure, so we can detect the finger pressure on an automotive interior, and then associate the pressure to an action, such as switch on the light of the car or other things like that.
So he also suggests that you connect to Ford. If you haven't yet, maybe Daniel can introduce you. That's wonderful. And Benjamin is asking, can it be implemented on any composite material? Great question.
Yes, sure. It can be implemented into any composite materials, so as carbon composite or fiber composite also. We have two solutions developing with the Sensity tech. The first one is using the material itself as a sensor, and then the embedded system will be connected directly to the material, and the material will become itself the sensor, or using a coating developed by our team, a sensitive coating, and then the embedded system will be connected to the coating, and the signal will be sent inside the coating, and the coating will be put on the surface of the material.
Wonderful. Okay, so thank you for everyone asking these questions. Please continue to ask those questions. Also, please don't forget to put your candidate that wins today our hearts and minds with composite solutions in the comments. I'm really curious to see who will be our hearts and minds winner today, which has nothing to do with the winner on the 23rd of November in Frankfurt, of course, of the booster competition of JEC Forum DACH. Now, Laetitia, I would like to, ask you a few questions based on an innovation model that I will be sharing now. So here's the share. So, sources of organic growth. McKinsey has put this on a paper. One of the reasons we do, composites or innovations, if you like, because of, we want to grow our company. First of all, how large is your company yet? Is it a small company? Are you a growing company?
Yes, we are, for the moment, a small company. We are 9%, but we will be 13 soon at the end of the year. And so we are growing. And then I think we are in the middle, a new source of organic growth. We are launching a new product because we are developing a disruptive technology, an innovative technology, and it is a new way to obtain data from the interaction suffered by a material, because there exist methods today, but they are not answering to the constraints of the industrials. For example, the strain gauges can be used on instrumented test bench, but not during the system exploitation, whereas the Sensity tech can be used on instrumented test bench to enhance data which will be not accessible previously. Also on production line to do non-destructive tests, and also during the system exploitation to do predictive maintenance. So it's really a new product on the market, on the composite market.
Okay, wonderful. So let me ask you the question. Are you operating now launching a new product variant? It could be also service, but in your case, it is a product really. Launching a new product, or are you developing actually a new business model? Where would you put yourself in and why?
I think in the new again, because yes, we are developing a new product, but also a service. We have both development at the Sensity, a product. As I said, the coating will be our product. So for automotive interior, for example, but also for composite monitoring, and also a survey that can be as a license, for example, using the algorithm we are developing, and it will be as a service for the industrials.
Okay. So my recommendation is always for innovators to look also to the next, developing a new business model. And by next, I don't mean with the business model that we are looking for the new Uber or for the new Netflix, but try to be different on the market, differentiate yourself on the market, because you become then later inimitable. You will be the original, and it will be very hard for the others to find yourself. So the next is basically having the highest competition advantage on the market. Thank you, Laetitia, for having us a look behind the scenes. I wish you all the best. And now I invite Jörg to the show, because with Jörg, I will now discuss the next slide. So that is Transform Innovation Performance. Just a few words on this one. Again, this is from McKinsey. You see, I have a favor for McKinsey because they are doing a great job. If someone from McKinsey watches this, kudos to you guys. You make a great job on innovation. So, of course, you got your strategy, Jörg, with your waste recycling products, and you will be pitching this also on the 23rd of November in Frankfurt to JEC FORUM DACH, the jury. My first question is, but do you have also other innovations in your pipeline? Because one of the things that are key to innovation management and performance is that you have a pipeline of innovations.
Exactly. So I like this slide a lot because it shows that it's always, everything is repeating a little bit, and we have to be flexible and innovative in the end, and how to reach a performance in this area. So for us, it happened to be that from the first ideas, up to date, there are so many innovations which join into the initial idea, to the initial innovation. Yeah? And I think this is how I read this McKinsey document, that the pipeline should be filled, but I experienced in a startup with tackling a big problem, a social problem, which we do, the pipeline is filling up every day. We are in the lucky circumstance that many different applications in the composite market need slightly different approaches for recycling. What our niche of getting the material prepared and ready for future steps, for future use of these materials. So we are in a very early phase of making something out of it to use it further on. And as we know, composites are composites. So we have many different things overlapping. So we need a broad spectrum. And yes, innovation performance comes for sure, like displayed here, to make it happen and to reconsider every day. Are we on the right track? Is our main focus point still the major market need also? Do we hit the price categories which will industry be ready to pay for, even if the topic is nice, like a green tech topic is always nice to have. But in the end, we are measured by our innovation performance. Are we meeting the needs of the market? And the legislation in our case is a very, very big focus on environmental legislation, and very deadlines are coming closer and even are getting pulled from 50 to 40 to 30. So yes.
Wonderful. So let's jump over intelligent execution, because we will come to that with the 8 essentials later on with Michael. Let's jump over to mobilize the organization. Many organizations, from my praxis with the European Commission, when I have these beneficiaries in my coachings, they seem to treat the innovation in a very small team. So that team is responsible for the innovation from the R&D until the market and business development. How do you guys handle the innovation? Is your organization entirely committed to that innovation? Do you engage your organization in this? Or is it also that you have a small team, working on a concrete innovation?
So this is maybe overlapping with what you asked Laetitita on the disruptive elements. So a startup, in my perspective, is a disruptive tool, or it develops in this direction because it tackles things the big industry cannot do in the same manner. And I see it with mobilizing the organization means to grow anyway. Every organization needs to grow. We try hard to grow fast, and we want to double up the team until spring. Why we do it is because this innovation pipeline is full. Yeah? So we need to go out, find people, good people. And if someone watches this on LinkedIn, please apply. We need the best talent. We need the best engineers in small companies because we have very challenging tasks. So we need very high talented people. We find them, luckily, but still we need more of them to make this growth happen. And then we are more attractive later on also for the big organizations. And then this merge between a startup idea, a technology we developed in a startup, and a big corporate can happen.
Wonderful. Thank you, Jörg, for having the look behind the scenes. Very, very professional. Thank you so much. And we have even a call to action now for the network. We are looking for jobs here. So next one is Michael. Michael, I got oh, sorry, that was wrong. Remove Jörg, and Michael is here now. Michael, I have now for you the following slide. Let's go to intelligent execution, and that is the 8 essentials of innovation. Let me introduce this model here. So in 2015, or slightly before, McKinsey has asked many CEOs that have performed, and now I need to underline that, have performed a successful innovation. Successful means it was, invented, it was drawn up as a business model, and then it was marketed in a successful way. So they have not asked innovators as such, but the successful ones. And then they came up with these 8 essentials. They have discovered that a successful innovation is running basically through these elements. And I'm just running through, very fast through this. Aspire means you want to grow through innovation. Choose, if you have a pipeline of innovation, which one it is. Discover your platform. Yeah, in my case, for example, I've discovered LinkedIn as my platform. Evolve is the business model, yeah, which can be still drawn up as a concept. And then it comes into the implementation phase, which is the acceleration process. Then, of course, you need to scale up your production and your network, extend your network, basically. And then again, we are at mobilizing. For me, this part is a bit misleading, that mobilizing is at the end. I would advise innovators always to put mobilize at far early as is possible. Mobilizing your network in the end, okay, I don't know how that study was basically taken up, but for me, mobilize should be a parallel Strang, we say in Germany, to all these essentials. But now to you, Michael, where is your ROB-in right now situated? Have you already discovered the platform? Have you already made the business model, or are you already implementing it in the market and you are trying to scale it up, for example?
So yes, and yes, and yes. that's actually the point. But I understand this theory more interactive in a way, or at least blurry between the phases. For me, classical innovation in engineering always means going a few steps further, taking smaller steps back, and then going more steps further. So it's just important not to forget the goal you are aiming for. For us at ANYBRID, we want to sell a machining technology in the end. So right now we want to demonstrate how customers can benefit from using our technology in their production. I'd say this is the beginning of the implementation phase in a way, but still we are going a few steps back to further evolve our technology to satisfy the customers' needs that are coming in every day. So with a few customers, we are even already starting to scale up in realizing first productions in serial production. So I see this more blurry in a way. So for us, when I looked at this slide, or I look at this slide, I see a lot of phases that we are in and that we are going further.
Yeah, absolutely, absolutely. This is certainly not as linear in reality as it looks like. Yeah, but this is the way how the diagram was basically displayed, so that visual learners can immediately catch the message of this 8 essentials. I find it very practical because it serves me like a checkbox. Yeah, whenever I talk to my coaches, I'm looking at, okay, which stage are we talking about right now? Because when you talk innovation, it can be messy. Yeah, the future is unknown. Are we talking now about the marketing side, the creative side? Where are we right now? So very good that you have already passed all these creative phases and are already implementing and already scaling up with some customers even. Wonderful. Okay, then I invite, last but not least, Robert. Let's get Robert into the stream and Michael out. Robert, so we will have now the next slide on the innovation management. Of course, let's talk about which type of innovator. I'm sorry. You are the critical segmentation one. Martin, I will come back to you with the innovator. I'm sorry, I've overlooked Martin. So Robert, yours is customer segmentation. How do you, and have you actually, studied the market? I mean, okay, this is a rhetorical question. Of course you did. You mentioned this already in your pitching. But how can I imagine, what have you done? And give us some examples. Where are your customers?
Yeah, so this is actually one of the big problems for us, tackling the market, because we did analyze the market, as you said, and we found that there are so many potential customers and so much potential out there as being a basis material for many applications that it's very hard to focus on the right one. So what we did is, right now we're offering samples to anybody who wants to buy them at a fairly low price to find out where their real interest lies. And we have customers from all over the world. So we have from China, Israel, Europe, a lot, obviously, US, customers who are asking for us. But we found that we have more and more segmentation in the markets. So we found that automotive and construction are the two big ones that they have most of the pain that we can solve, that we can tackle right now. And we are segmenting by those two application areas.
Yeah, let me come then to another one maybe that can ease the thinking here, and that is the next slide, which is coming here: market definition, market potential. So many innovators are looking at the market potential as such. It's a great way to start, and you find a lot of literature, and even JEC does a great job on this. Yeah, the market potential of composites, for example, in the different market sectors, and also the contributors in the JEC magazine do a great job. But what is important is to ask yourself which of the market is available to you. Now, available could mean that you need to be have proximity to your customers, be in the same time zone, same territory, like in Europe, for example. But not only that, it has to be also a qualified available market. So in your case, for example, not everyone will require a basalt fiber that has an aluminium sizing or binder or coating on top of it, because they may have not the looms, the weaving looms or the biaxial machines available. So you need to qualify that market. And then, of course, there's a target market, like you said, for example, the automotive industry. And then, of course, the penetrated market. So the penetrated market is easy. It's the ones that you are already serving now. So if you look at these markets, where do you struggle the most right now, Robert? Or is it maybe that you say, okay, maybe I need to focus on one of these circles?
So by now we have target markets, and we also know our penetrated market. But the thing is, where we do struggle a bit is at looking at the market that's not there yet, because in our case we have a new base material which is so much cheaper than what was there before, that many new applications are possible that were not conceivable before. Just one example is our material is being used as a wallpaper to shield off rooms, and so far metal fibers were just too expensive to make a wallpaper out of them. So these new markets, which are further down the process chain for us, obviously, defining them is very hard for us. So that's why we try to focus on existing things and then to build those new things to learn how they can grow.
Yeah, very good process. And maybe this is a nice bridge now to Martin that I take on the screen right now. I've had a different row here, so I'm selecting the right one for Martin. And Robert, please remain in the stream for now. I will do all you together now on this exercise. So the question becomes now, which type of innovator are you? Robert, you mentioned that you have been or are at the Aachen Institute, yeah? And Martin, you are an SME, small, medium-sized enterprise, correct? So my question to Martin is, with your Spindle, what type of innovation have you pursued here? Did you have a vision? Have you made a strategic move with your Spindle? Did you discover it somehow? Did you follow some other market entries, or did you experiment and find this can be used for a spindle?
Yeah, so our way to the innovation or to the spindles was almost quite forward. It started as a research project from the Institute for Lightweight Design, where I was employed, or actually I was directly employed to tackle this project. And so in the beginning, it was only the question, okay, how can we use carbon fiber? And then, of course, in the beginning was this vision of me to say, let's make all the structure out of carbon fiber, because if we would have followed current people, how they do it before, like in the 80s and in the beginning of the 90s, people try to do this because it's such an obvious choice, but they always used a lot of metal. And so I thought, okay, people tried it already and it obviously didn't work. So we need a new vision. And But of course, from the vision, you don't get a finished product. You have a lot of detailed problems where you need some strategies, of course, that you need to follow, some way of designing your parts, so that you don't run around without a head and run against walls all the time. But then, of course, you need to do a lot of experiments. Yeah. So I think all parts of those innovative types, they have to come together in depending on what kind of problem you're solving right now. In the beginning, of course, you need some sort of vision, but then under this vision, all the little steps where you always need to find new ways to solve something that is ages old in steel. Basically, everything that was done in steel before, we have to rethink, and think, okay, what can we do better now with carbon fiber? Do we have to drill long holes, or can we integrate them directly in the manufacturing process? Or do we need to have some special direction-dependent mechanical properties? How can we leverage the advantages? So the vision was always using carbon fiber, and then lots of experiments.
So let's help Robert out now. Robert, you are backed up by Michael, who says, exactly, Robert, same with us. We have to create new markets for our technology. That's what I'd call disruptive. So if we take that as granted, is there a merit in saying that you have to create a vision or to create a strategic innovation or move in the market? Because discovery would be not possible. You have to move somehow, but do you move a vision to, and how would that vision look like? Or do you move with a strategic element that you say, okay, we have some competition available, we have some other fibers available that we will combat here?
So I think it's a mixture, and I can only talk about our story, obviously.
Yeah.
But I think that there is something that is with vision, but also entrepreneurship. Because when we started, we had a vision, fiber reinforced plastics, composites are way too complicated, the production is way too long, and that's why they're way too expensive. And so we figured there must be a way out there to make it cheap and affordable. So this is the vision that we had and that we followed. But then over the course of our development, of our testing, we need to strategize and experiment because at some point, our development took longer. The market reacted very differently from what we were thinking. So you have to pivot as an entrepreneur and understand the needs and how your vision can solve those needs before it can really take off to change a lot of things, be disruptive.
Okay, wonderful. So let me take now this presentation out for a moment and everyone into the live stream. So we are coming slowly to the end. We have already 1 hour, 7 minutes here, and some are jumping off already because we are over our time. So for everyone who has jumped in later during this show, this was a fantastic show with startups, with excellent technical innovations. So go back after this live stream and watch this live at the comfort of your time and zones at home. It was very, very interesting to have you all guys here on board. Everyone has pitched their ideas, and Yannick has said, for example, he has 2 winners today. His mind winner is Robert, and his heart winner I saw somewhere. Yeah, here is Touch Sensity, French Touch. Actually, he avoids to mention Laetitita here now. that I will do because this is also a personal presentation today here. So thank you very much, everyone. Of course, it's not always important to be a winner. It's also important to be on the courtyard, and you have been all on the courtyard right now. Good. We do a final round now. Everyone, give me a sort of, or the community, a sort of a call to action. What would be if you had one wish that people should do after this LinkedIn Live? Robert, you first. We go clockwise.
So one wish, think about how to make people for the life for others affordable and easy, either through technology, development, or vaccination.
Wonderful. Then Martin, what's your call to action?
Yeah, of course, since I can't wish world peace and everybody healthy, so I have to settle for the second best and wish that everybody who has to machine parts has to order carbon fiber spindles, and we will supply them.
Wonderful. Jörg?
Yeah, sure. Everyone who is interested to get in touch, we are very happy to get in details about our technology. And I want to remind you that the recycling of all kinds of materials is a big challenge and a big opportunity at the same time. We are dedicated to do so. And yeah, hopefully get in touch. Thank you.
Wonderful. Okay. Then we have Laetitia, one more time. What is your call to action?
So think to the monitoring of your structure and the health of your materials. And so if you have some needs about it, please contact me and I would be very, very pleased to talk to you more about the technology we are developing and talk about your application.
Okay, great. And last but not least, Michael. Well, yeah, thanks for everybody listening and watching us today. I'm just looking forward to get out of this pandemic situation somehow, getting out there again together, meeting again in person, and then, well, I'd say till then, follow us on LinkedIn. Yes, wonderful. Okay, yeah, last but not least, once again, thank you, JEC Forum DACH, Eric. And I want to mention Nelly. She has organized our nice group here. Thank you so much for your support for this very, very interesting startup. So are you all present at JEC Forum DACH on the 23rd of November? Who is there?
Sure.
So everyone is there. Okay, and how are the feelings? We need to make one more round, I'm sorry. How are the feelings to meet in person again? Robert? You're muted. You're muted. Martin, how are your feelings?
Yes, sorry, Robert, you were muted. My feelings, yeah, we are very looking forward. We had 2 years without trade fairs and meeting people, so it will be great to see people again.
Okay, Michael?
Well, same for me. I'm just looking forward to get out here again. Okay, Laetitia?
Yeah, the same for me, looking to have an in-person event again.
Okay, wonderful. Jörg?
Yeah, we already had one in-person meeting in Germany, Stuttgart, 2 weeks ago, and it was great. It was a conference on environmental technology. So I'm looking forward also to meet you again. And I can tell you already, it's really cool to do it again.
Wonderful. And now, Robert, one more time. Now we can hear you.
Yeah, I'm looking forward to. I have so many friends in the composite industry I haven't seen for 2 years now. Looking forward to meet everybody again.
Wonderful. Okay, Benjamin says, look forward to welcome you all in Frankfurt. The same from my side. And all excellent presentations, says Daniel. Daniel, thank you so much. Everyone who has joined our conversation, we appreciate that a lot. So this was a very special one because it, I've spoken from my heart. Innovation is very, very important these days. Yeah, keep innovating, people, and you have seen some 5 excellent examples on how innovation is done. You have seen also how innovation is managed. It's not only the creative part, you need to also manage the innovation. And I've seen a lot of proof today that these finalists, they are managing their innovation in a very professional way. Congratulations to you all of you. Yeah, and finally, bye-bye and see you in Frankfurt.
Thank you.
Bye.
Bye-bye.
Thank you. Bye.